Hey, all right. Well, yeah, like David said, this is going to be a very exciting webinar about nPower's power surfacing add-in for SolidWorks. Hello, everyone. My name is Kevin, and I'd like to welcome you all to our latest Novedge Webinar Series episode. Today, we are partnering with 3D artist and educator Sue Blackman and the nPower team to discuss nPower's latest add-in, power surfacing for SolidWorks. nPower's power surfacing plugin provides organic surface modeling through an innovative unification of subD modeling and SolidWorks features. You can quickly block in aesthetically pleasing organic surfaces or volumes, convert to NURBS, and then go on to add your favorite SolidWorks touches. We'll discuss all this and see how easy it can be to edit and manipulate changes to your model through power surfacing's hand-on interface. Thank you for taking the plunge with us today. We have the IntegrityWare team with us behind the scenes, and today we're going to learn more with Sue's live demonstration. And for those of you who don't know who Sue is, Sue Blackman is a 3D artist, author, and educator. She has taught classes in the engineering and drafting departments of top-rated community colleges and has authored for Apress, lynda.com, and AMC Siggraph. She specializes in combining game technology with CAD data, and she has been involved with the development of 3D applications, training materials, and workflow analysis for well over a decade. Working behind the scenes, we have of us Gary Crocker and David Gill. Gary is the CTO and founder of IntegrityWare, and David is the president of IntegrityWare as well. Together, they have over 30 years of experience in CAD, working in computer graphics. They previously worked at Computer Vision, GE, and also Autodesk as well. So today's presentation is about 40 minutes long, and then afterwards we'll have a brief Q&A session where the team from nPower and IntegrityWare will answer your questions live. So feel free to submit your own to us at any time into the chat window below. Before we get going with the presentation, here's an overview of what we do at Novedge. The Novedge Webinar Series is brought to you by Novedge.com. As one of the largest online design software stores, we offer a huge assortment of software solutions that cater to virtually every designer's need. If you are interested in purchasing the digital version of nPower's power surfacing for SolidWorks, it is available worldwide from us at Novedge. So to learn more about this and the rest of our nPower catalog, you are welcome to call and speak with our representative, Bob Baer. You can reach him by his email address, bob@novedge.com. And once my mouse starts working, there we go. Yeah, and then to get a glimpse at who is changing the world of design one step at a time, please visit Novedge's very own blog. Every week, our interviews shine a light on those innovators whose work break out from the norm, and I do want to mention that answers from your webinar questions from today's webinar will be shared here as well. So for more details, please visit blog.novedge.com. And to stay up to date with what's happening in the design industry, along with Novedge's latest webinars and product promos, do like us on Facebook. Coming up next week, based on the manual of the same name, Light Plot Deconstructed is a short and easy-to-follow look at the way Greg Hilmer uses tools available in Vectorworks Spotlight and RenderWorks 2014 to draft a light plot. Line weight, symbols, layer, and class options, and other choices will be discussed in this brief yet in-depth presentation. The webinar is free and will last about an hour with a Q&A session as well. So if you want to sign up for this free event, do check out novedge.com/webinar/89. And last but not least, today's webinar is being recorded, so if you want to rewatch this, feel free to check out vimeo.com/novedge and youtube.com/novedge by today's end. I'm sure it will be ready in 720p HD as well. So with that said, Sue, are you ready?
I am ready.
Cool. Awesome. All right. I will make you the presenter right about now. Take it away.
Okay. Okay, well, the first thing I like to show is something that's a little more finished. So I've kind of made a fancy version of our circular saw model that we use to show. It has way too many features to sit there and wait for it to convert those. So I'm going to switch over and close this guy out. And I'll bring an earlier version without all the nice materials and everything. So the first thing we like to do is kind of give you a real quick overview on why you might like to use the power surfacing. And one of the really nice features is how quickly you can edit things. So I'm going to select my power body here, and this is it. This is a power surfacing feature. And I'll go into edit mode. want to make a few changes. And I always go the wrong direction depending on what model I'm working with. And maybe I've decided that this handle on the front is a little bit too large for my hand, so I'm going to move it in a little bit. And maybe our designer comes along and says, well, you know, I'd like to change the shape of the handle a bit. So I'm going to pull that up a bit here and maybe tuck it in a little here. And everything stays nice and smooth, and we can convert. And something that could have taken a long time with traditional surfacing in SolidWorks is very quick and easy to do. Notice also that I've got an offset surface on this sort of handle grip thing here, and it followed right along. The other thing I'm going to show you here is that I've built some SolidWorks features off of the back end here, and to show you how that converts, I'm going to go back into my power body. And because this is a flat surface, we can register it and create a sketch off it, which is what I've done. So if we change this now, and I'm going to rotate it a little and then pull it down a bit, and when we convert, you'll see that the SolidWorks features have picked up the changes. And there we go. So this is what we always like to start off with, just to kind of give you a taste of how quickly and easily you can make edits on the power surfacing object. So the next thing I want to do is I kind of want to go over what subDs are and why we want to use them, because they're quite a bit different than what you're used to in SolidWorks. Well, the first thing is that they convert to Class A surfaces, and then they're curvature continuous, which means we're going to get some really nice smooth curves here. The closest thing I can show you, and I'm going to close this guy out now, is if you're used to using spline curves on sketches in SolidWorks, they're very similar to that in that if I tweak one area, there's a lot more areas that can get affected by it. And that's the one thing you want to remember with the subDs. It's very similar to that, only in 3D this time. So let's go ahead and look at one. I'll go ahead and close this guy out. And there's several different ways to start subDs, and I'm going to create a new one with our creation tools. And I think I need to not do it in this particular file. Let me make a new file real quick. I've got another file open in here that I wanted to save some time on, so it just tried to open it on that. So in this file, I'm going to go ahead and use my creation tools to create a box. Now, you can see that this thing, well, the outline looks like a box, but the middle part doesn't. And that's sort of one of the key things of subdivision surfaces is it has what's called a control mesh, and I'm going to switch over under viewing here. This is the control mesh, and this is where we're actually getting our data from. But this is the subD, center one here, and this is what actually gets converted when it goes into the SolidWorks side. And as a default, you're generally going to see the subD and the cage represents that control mesh. So the next thing that's good to know about subDs is that if they have, the more edges they have on them, the closer they're going to resemble that control mesh. So remember, the control mesh looks like this. Here's our subD. going to go back to our subD plus control mesh here, the cage. And if I change the number of segments, you're going to see that it starts approximating the shape of that original cube. Now the only problem with this is it's going to be harder to work with. So we suggest that the best workflow is to stay with as few of segments or edges as possible until you absolutely have to use, until you absolutely need them. So let's see here. The other thing that's good to know about subDs, and I'm going to go ahead and do a OK on this. So we've created our subD. We're now in edit mode. And the other thing that's good to know about them is levels of subD. So right now, as a default, this guy came in with 3 levels of subdivision. And if I take it down to 2, then 1, then 0, you can see how the subdividing sucks the mesh down into that nice, smooth, curved shape. We usually like to work in 3 levels, so I'm going to go ahead and put it back. Now, what I'd like to do is I'd like to just go through the tools really quickly for those of you who haven't seen this before. So I'm going to cancel this guy. And I'm going to start with my basic gas can demonstration. So once again, I'm going to go to Creation Tools, Create Box. And I know that for this demonstration, I need 10 inches by 6 inches by 8 inches, and that gives me my start. And in this particular model, with this one, I prefer to start my modeling in control mesh mode. And I'm going to select OK, and now I'm in editing mode. And one of the differences with this is that we're actually transforming, move, rotate, scale, different sub-objects. Right now I've got a face selected. I'll now select a vertex, and there's an edge. And we can affect these things directly. First thing I want to do with this guy is I'm going to scale in the top of my gas can. And notice that our triad it's got a lot of controls on it. We can do a uniform scale from the center. We can do a non-uniform scale, which is what I'm going to do. And we can also constrain in the Cartesian directions here. So I've got my scale done. And now another feature that we like to use is if I right-click in my right-click menu, it's showing that I'm using, I can select any type of sub-object, and I'll switch back and forth occasionally. But I'm going to double-click in the center of one of my edges, and it selects what's called an edge ring, a ring of edges that loops around the object. Once I've got that, I can right-click and say, let's create a loop there. In the command panel here, I can change the number of loops. I could also change it with the gizmo. And when I'm finished and I like it, I can right-click or I can click the OK button. I'm a right-clicker, so that's what I'm doing this time. So I've set up for my shape here, and now I'm going to select a couple of faces on the top. SubDs, by the way, like to have quads, 4-sided faces. We can get away with 3-sided occasionally and maybe 5-sided, but your result is going to be a lot smoother and nicer if you can keep to quads. Another nice feature we've got is that a lot of our controls, a lot of our features can be done with a quick key. If I hold my A key down on my keyboard and hover over the Y direction axis and pull, I can do a quick extrude. It doesn't give me all the options I'd get when I'm in the control panel, but sometimes you don't need them. So I've just extruded. I've increased the size here. I'm going to scale them in. And now I'm going to go over and select this edge. Notice our edges turn yellow when we hover and then blue when they're selected. And now I'm going to go ahead and pull this back. And what I've done is I've started to define the front shape of my gas can. The spout's going to go there eventually. Before I get any further, I'm going to use the A key again, holding the A key down, and I'm going to hover. This time we get a preview of an inset loop. So I'm going to click to make it permanent. And then I can go ahead and select my face again up here. And holding my A key, I'm going to extrude this. And I'm going to rotate it. Now the problem is, as soon as I rotate it, you can see that the dimensions have sort of changed from because of the orientation. They haven't really changed. They just look different. And one of the things we can do is we can switch between world, screen, and the object itself. So I've changed to the object coordinates, and now I can scale this guy back down and get him right where I want him. I'll go ahead and hold my A key again and extrude, give it a little rotation. And now I want to go ahead and bridge that gap. I'll go ahead and hold my A key and extrude one more time over here. And then I'm going to select the two faces I want to join. And I'm going to bridge them. Now I can use my right-click menu and choose Bridge from here. And we've also got most of the tools up in the ribbon as well. I'm a right-click person, so I'm going to use this way. And we've got an option to add segments. This time I'm going to right-click and say, okay, I like it how it is. And while I'm here, I'm going to select these new faces and scale them in here, so I can get my hands around the handle of this. Now, this would be a really good time to switch back over to the subD display and see what it's looking like. So our top part's starting to look pretty decent, but our bottom part, you can see that there still isn't enough geometry there to sort of fill it out to that original control mesh. So I'm going to go ahead now and switch over to edges again, and I'm going to insert some loops. This time I'm going to add them over in the control panel. So I've got two. And here's a fun thing we can do here. We can pinch or spread loops apart. And as soon as I spread it, you can see how it's now starting to fill the shape out of that control mesh. If I switch over to the control mesh right now, you'll see how much closer it is than it was before. I'll go ahead and right-click to finish the command. And then I want to do one more insert loop to sort of even things out. I'm going to switch now to face mode and drag a region. And you notice that it selects just like SolidWorks. We're a gold, SolidWorks Gold product, so we try to make everything as SolidWorksy as possible for you guys. And with this selection set, I'm going to try something a little different. I'm going to right-click, and from my right-click menu, I'm going to weight the edges to 100%. And you're going to see what happens here in a sec. So it's changed the way the edges come together. And now I'm going to do one more. I'm going to do an offset. And I'm also going to right-click and then weight its edges. And then I'm going to scale it. So we now have a much more interesting shape on our gas can here. At this point, we can go ahead and convert. So as long as we aren't in any of our tools over here, the green check mark is going to convert to the NURBS model, CAD model. And now we can see what it looks like. And here he is in the feature list. And now I can go ahead and, if I hit the right one of these, set it up to make my spout. So this is the SolidWorks part now. So I'll go ahead and choose my front plane. I'll make a new sketch on it. And I want to do a center line, a construction line, and I'm just going to start it, right about here, so about like that. And with that, now I've got a nice setup to make some reference geometry at plane. Select. And we're good on the plane now. And I'm just going to make a simple circle, make my sketch on that new plane. I'm not going to dimension it or anything. You guys all know how to do that. And go ahead and extrude it. So, and you can see that it's become, it's all part of the feature tree. Everything's happy here. I like to, being a longtime Max user, one of my favorite things in SolidWorks is fillets. So first thing I'm going to do is I'm going to select the place where the spout comes together, and I'm going to give it a fillet of about 0.2. Nice big old fillet. There we go on that one. Now it would be really nice to add some fillets over to our creased edges, our edges that had 100% weight. And that's one of the things that we're able to do with that hard edge. So I'm going to open my fillet again, set this one to 0.05, and select some edges here, and say OK. So there we go. Got some nice little bitty edges. If I zoom in, you can see them where they've been filleted. And my next favorite thing with SolidWorks is being able to do shell. I'm going to add a shell on this and just leave it on the default. And there we go. And we can use the sectioning tool to look at it and see what it's done. Now, you saw before with circular saw housing that one of the things we really like with this product is to be able to go back and edit it quickly. So I'm going to go ahead and I'm going to go back to my power body into edit mode, and I'll just grab a couple of, well, more than a couple. I'll just grab a few vertices and give them a little pull and convert again. And there we go. Our features have remained intact. Occasionally you'll get them where they get lost, and you just have to go back in and select the edges or faces that you were using. But usually it's pretty safe. Okay, now probably I'm guessing if you guys could be talking to me right now, you'd say, well, how do I get something exact? Because you've just sort of pulled things here and there and not worried too much about a scale. And that's a good question. Because these things do act a little differently than what we're used to. So the next thing I want to show you is how I went about making the handle on that circular saw. So I'll go ahead and close this guy out. And I'll bring in our next victim, which is housing base start. And what I've done here is I've used a sketch plane. So this is a drawing I've got, and I'm using it as a template. I've already got a power body that I made for this thing, but I'm going to go ahead and add a second one here. So in Power Surfacing tab, create box. And I'm not going to worry about the size of it. I'll just accept it as is because it's very quick to go in and select all of it and then scale it down and move it into position. And I'm only going to be I'm just sort of roughing it in at this point. So I'll hold my A key down and extrude.
There was a question about A key. they ask what it does.
The A key, okay, so I'm answering a question about what the A key does. The A key, well, we use A, and for us it stands for add. It adds functionality. So it's a shortcut to do a lot of the regular tools. So I just use the A key to pull this face out, which is actually the same thing as using an extrude, which we can either get from the ribbon or the right-click menu. It doesn't give us as many options, but it's a very quick way to block things in. So once again, I'll hold the A key and pull one of my transforms here. And I can select the bottom face here, A key again. It's not happy with me. There we go. And then I'll do a few over on the other side. And it's really rough. But at this point, what I want to do is I want to go go down in the viewing area here, and I'm going to turn on transparency. And I can make that more transparent, so now I can see my template object. You can also use sketches as a template object as well. So with that showing, now I can start pulling my model into position. And remember, it's very similar to the spline curves. If you move one, the other may move. So you never want to spend too much time at first when you're setting it up. You always go back and refine it after you've got everything closer. And I've kind of found that when you think you need to move something in, you probably want to go to the next one along the line and move it the opposite direction. And it's fairly quick to get a pretty accurate fit on that. Another thing we can do is we can select a face, and I'm going to extrude this one again. Right-click to finish the extrude. And if we give a 100% edge weight to this guy, we've now got something that we could, if we wanted to, snap to a plane. It won't have the relationship where it's parametric, but it can always be re-snapped. So once you've put a hard edge, a full 100% edge weight on something, it can be put into a position where you can get the dimensions on it. Okay.
There's a way to snap the vertices too.
Yeah, and we can also snap vertices as well. There's a lot of advanced tools I probably won't get to, but we've got a lot of alignment tools and other things in here. Okay, so the next type of the next workflow with this, so we've seen using a template to sort of help make the shape. The next thing I want to show you is a surface modeling technique. I'm going to cancel this guy, close him out. We'll bring in our next file here. And this time I'm going to use a sketch. So this is a regular SolidWorks sketch. And you can see I made it with straight lines. We could make it with curves, but the curves would need to be approximated anyway at this stage. And so it's always better to think of your subDs in sort of straight faces. Now with this guy, I'm going to use the option up here in the left corner to create from sketch. And you're going to see something funny happen here. You're looking at that and you're saying, well, wait a minute, what happened to that shape? Because right now we've got a volume that is within a rectangular bounding box. And that goes back to the fact that the subDs prefer to be quads, and anytime you get over about 5 sides on a face, it's going to have trouble. Or not trouble, but it's not going to look like you expect it to. So what we've got is an option that if you want to start from a sketch that has more than 4 sides, you can use Create Planar SubD from Sketch. That, we now get something much more recognizable. In the control mesh, we've got a nice accurate version of this. If I turn it over, you can see that it's just a surface. But if I went to the SubD at this early stage, you'd see that it has pretty weird looking geometry happening. So I'm going to go back to my control mesh, and I'm going to go ahead and accept this. So now we're in edit mode again. And the first thing we want to do with this guy, and this is a classic SubD exercise, a spoon. The first thing we want to do is start building those quads. So from my right-click menu, I'm going to use Insert Edges. And I want to start cutting and defining quads. And we've got a good, strong snap to vertices. Now, it would be really nice here, and it is. I've already done this today, so I've got my angle snapping already turned on. And you can see it's going to snap to horizontal and vertical, which makes my life easier. I'm going to come down, and here's a 5-sided. We'll let him get away with being there. And I'll add a few more edges here. When I get to this one, I'm going to make it a triangular, a 3-sided face. And once we do a mirror on this, we'll be able to turn it back into a quad. I'll make the rest of this. Come down here, and we'll make one more triangular face. And then right-click to finish the command. So this is one of the workflows that it doesn't really matter what order you do them in for the most part. So I'm going to switch over to face right now, and I'll pull up the handle bit here, and I'll drop the bowl of my spoon. Yes, this is a spoon. It will be eventually. And I can also go ahead and start the bend on my spoon on the handle. And it's pretty rough right now, but if we switched over to SubD, because that's what it will be doing eventually, you can see that we've got a much smoother looking result. And maybe I want to adjust this guy a little bit. At this point, it would probably be a really good idea to go ahead and mirror. Now, mirror in power surfacing isn't the same as the mirror in the rest of SolidWorks. It's more of an edit thing. So I'm going to go ahead and say mirror. And we need to select 2 edges to define the mirror plane. And notice it's blue. That shows an open edge. And I could go ahead and right-click to accept the mirror. And now I'm going to pull a few of my vertices up to kind of give a little bit of crown to my handle. Like so. And I can also adjust my sides. I am in mirror mode. And we have one live side and one side that does the actual mirror. So I've sort of adjusted a little bit there. At some point now, if we want to clean up these 3-sided faces, what we can do is we can go ahead and unify mirror. So now this has turned it into a single unified mesh, well, surface actually. And you can see that one of the things that happened was that we lost that point on the end of the handle. Now we might like to get that back, and besides being able to weight edges, we can also weight vertices. So I'm going to open my Advanced tab down here, and I'm going to turn on Weight. And this is going to let me adjust this to see just how much curvature I want on that end of that spoon handle. And when I'm finished, I can close the checkbox. One more thing I want to do before I add some thickness to my spoon is I'm going to switch over to Edge, and I'm going to take out these two center edges and remove them. From the right-click menu, use the eraser here, and they're kind of funny shaped quads, but they're now quads again, which is going to be a much happier way to convert. Maybe I'll tug my one little vertex here. And the problem right now is that we still have a surface. Power surfacing has its own thicken command, which I'm going to show you from the power surfacing menu. Specialized tools, thicken. Now this guy's different than SolidWorks in that it's never going to fail. It might go inside out, it might go over things, but it's never going to fail. So I'm going to set this to minus 10% on the thickness. And the nice thing about this is that now you can go in and you can continue to edit this thing. Right-click to finish the thicken. And I'm going to pull down these two edges because anyone who's had any experience with traditionally made silverware knows that it was stamped out of a much thicker piece, so that you're going to have a thicker area here. So we can adjust the thickness exactly how we want it. And then when we're ready, we'll go ahead and convert and see what it looks like. And there it is. So that's a good classic exercise for surface modeling. Do we have any questions here?
Yeah, there are a bunch, but
okay,
we can answer some of them later. But
let's see what we've got.
The difference between weighting and pulling the point, good one to answer right now.
Okay, so the question on this one was, what's the difference between weighting the point on the handle and, uh-oh, it jumped. I lost it here. Weighting the point on the handle and pulling the point on the spoon in. One, I'm just moving the vertex, and if you think back to your splines, remember one point in the spline, the others will kind of tweak a little, or the curves in between. So that's sort of what happened there.
It maintains the continuity, the curvature. It stays curvature continuous if you just pull on it.
Yeah.
But if you crease it, you change the continuity.
Yeah, if you weight something, you increase the curvature around it. Whereas you just pulled it, it still would have that same sort of radius of curvature around it.
Right. Does that make sense? We can answer most of the questions later, but that one was related to the...
Here's one for you, Gary.
No.
Set a dimension on the thicken? No.
No, we can't dimension that precisely yet. That is something that's on our list. We've had other requests for that.
In the future.
Yeah, it's a future thing. Okay, so the next thing, so we've seen a little bit of surface modeling. We've seen using a template, and one of the things that I really wanted to show you guys is boundaries, because I think it's something that most people, if you're experimenting with power surfacing, you're not going to sort of pick up on it, and I want to show you the importance of it. So I'll go ahead and I'll kill my spoon here, and I'm going to bring up boundary test. So this is kind of a funny looking model I've made, and you'll see why in a minute. And what I want you to do is I want you to look at where the edges are on this thing. And when I convert it, you'll see where they were in the subD. So I'm going to go into edit mode, and so you can see that it lost several of the edges. It optimized them. And what's happening is when we convert, we have options here. So under feature creation settings, right now my type is normal. And that was where we had a lot of optimization happening. If I choose one-to-one planar and convert, you'll see that it will retain, oops, sorry, wrong one. I'm going to go back to that. Okay. One-to-one NURBS is what I meant to hit. Okay, one-to-one NURBS. One-to-one NURBS is going to retain all of the edges we had in the subD. So you're thinking, well, why is that important? Well, the other thing is, why would I want it to have that many? And that's the whole point of this, is sometimes you don't. So back in edit mode, I'm going to select some faces. Oops, too many. There we go. And we've got from the Power Surfacing menu, Specialized Tools, what's called Boundary. And we can define a boundary. Those of you guys who are used to working with polygons will recognize this as a material ID. But just like in any other 3D package, a material ID is usually able to be used for several different purposes. So we're going to define our boundary. Notice now that it has this light green, this sort of mint green colored edge. The hard edges, the 100% weighted edge, the purple color still takes precedence. But if it wasn't there, that would be green as well. And what this allows us to do is once I convert, oops, yeah, and if I remember to change the conversion, which I obviously forgot, back to normal, I've now got edges here, and I can use this to actually apply material. So I'll go for plastic, high gloss, and put a color on it. So that's pretty straightforward. But the one I want to show you, and this is probably more important than anything else here, is I've got a sketch. I'm going to turn it on here for a sec. And what I want to do is I want to do an offset surface and a trim and everything. So I'm going to select my surface, insert, surface, offset. I'll give it a nice big 1 so we can see what it looks like. And then I'm going to go back in and do a trim. As I delete this guy. Okay, now I've got this one, keep selection. And so we've got our surface sticking out like that. And I'll go ahead and put a thicken on it, give it a 1 just like the other one had. And now we've got a nice little bit of geometry sticking out here. So what's going to happen is when I go back, and if I change something, let me hide this back for a minute. When I go back into the power body and make a change, you're going to see something happen. And this is one of the important things about boundaries. So I'm going to go back into edit mode. And if I disrupt the face count or the face numbering that happens internally by doing something silly like an offset and maybe a wedge edge weight there. If I now convert this guy, what happens is our trim, our offset and our trim actually got moved over here because that's where it thought that face was. So to avoid that, what we want to do is define a face to use for the surface in the first place. Now, it's going to take longer to undo this guy than it would to just open one that's ready for us. So I'm going to close this guy. And I'm going to pull up boundary test B if I can find it. Here it is. And this guy. I'll go ahead and go back to my edit. And this time I'm going to set a boundary on this area because that's about where that sketch is. So power surfacing, specialized tools, boundary, define boundary. And now I can go and convert to my surface offset. Give it a 1. Do my trim. Wait a minute. Learn my lesson this time. I'm going to pick my sketch first. So surface, trim, and I've got our nice little part sticking out again. We'll give them the thicken like we did before. So now we're basically back to where we were before. And now if I go back to my power body and go into edit mode, we still have our boundary up here. But now if I go here and do that same destructive thing I did on the last one, offset, and I'll just crease it just because I like it. If I convert now, you'll see that now it's enabled us to retain the correct surface on that. So that's a really important concept to understand.
Before you go out, could you show the curvature comb?
One of the customers was asking for the curvature.
Curvature comb, right. Help me out on that one. That should be evaluate. And should be in here, right?
Do the zebra.
We do zebra.
Yeah, let's do zebra instead.
Okay, we'll do zebra instead.
See how it's nice smooth transitions between those surfaces, so its curvature is continuous.
Okay.
I don't think we know how to show the combs.
I do, but I don't remember where it is right now.
Check on click turn zebra.
Okay. Okay.
That's okay. Just
So, how are we doing, Kevin? How are we doing on time?
Let's see. I think we're doing okay. We're getting close. We have about 10 more minutes, but if you guys want to go over a little bit more, I think the attendees wouldn't mind too.
Okay.
Yeah.
So I want to show I want to show one last sort of technique or workflow that we found people using the power surfacing for. Something we never thought of at the start, but as soon as they suggested it, we said, oh, we can do that. So I'm going to close this guy out and see if I can get back to this folder. Okay, there we go. Okay. So what I've got here is we've got a car body, and the thing that the customer wanted to do was take something that had a lot of detail and get rid of the detail. And
maintain the continuity.
And maintain the continuity. Dave can explain a little bit more while I'm converting here.
Yeah, the customer is modifying car bodies, and he wanted to delete out some of the features, but he wanted to maintain the surface continuity. And so what Sue's going to show you is how we can patch this area back in, and instead of making it flat, we actually use the continuity of the joining surfaces to create a nice curvature continuous surface across the whole surface.
Yeah, that's where the gas tank hole is.
That's where the gas tank was.
It was. So she's going to show us how to patch that in and make it smooth. This was a model which was downloaded from the Turbo Squid website, and they have lots of very high-quality sub-D models there that you can import in here and convert.
Yeah, so we brought this one in as an OBJ, by the way. So this is what it looked like originally, and I deleted my selected parts here. And then what I want to do is I want to select an edge, and I want to fill that hole. So this is our fill face tool. But the problem is that it sort of stretches across just willy-nilly. You know, wherever the points happen to be, that's where it's going. So just like on the spoon, we're going to want to recreate some edges. And I may have to move in here to get my snaps in good position. And I'm going to happily, I need to undo that. I've got too far on it. I wasn't watching my snaps. Here up to here. And this one over to here. Here. There. And you can see I've got kind of a little bit of a problem here in that the edges don't match up. So what I'm going to do is I'm going to switch over to Edge, and I'm going to select an edge ring and insert an edge, right-click to say OK, and I've got one more little piece here I need to manually connect with my Insert Edges tool. So, and then I can go ahead and I can select my new faces that still are not smooth and continuous with the rest. But I'll select them. And the next thing we're going to do is we're going to use something called Curve Selected. Now I'm going to kind of turn this a little bit so maybe you'll be able to see what happens when I hit it. So I'm going to go to Power Surfacing, Specialized Tools, and Curve Selected. I don't know if you caught it, but I'm going to do an undo. And now you can see that it has, wait a minute, what happened to my redo on that? I lost my redo. So, Specialized Tools, Curve Selected, you kind of pop out a little bit. And now if we go to the subD display, and if I deselect that, kind of look at the side, you can see how smooth it's become.
You can turn the edges off.
Turn the edges off and just show it.
And we can also turn our edges off, turn off my vertices and edges, like so. And we've also got zebra stripes that we can use in here as well. Okay, so that's sort of that's about the end of what I wanted to show. So I think we can take some questions now.
Kevin will go through them. He'll ask us.
All right. Okay. Let's see where we at. Let's see. I know you guys answered a number of questions already. Steve had one. Do we answer the one about educational pricing options from Steve? Hello?
What was the question on
Educational pricing.
Oh, the educational pricing is $195 for an individual seat, and we have volume discounts for universities and larger educational organizations.
Cool. Okay. And then did we also answer Steve's question about the sharp edges of the Thinken? Are the sharp edges of the Thinken controllable? Does the Thinken always make creasable edges?
It always makes crease.
It makes creased edges, but you can always go and change the creases.
Okay. Was there anyone in particular that you guys, there is one from Vadim. Did we cover that one by any chance? Or
which one?
The one at 11:44 a.m. I could read it out loud too. This is from Vadim. I have a question related to the thicken command for surfaces. What does the percentage in the thicken command stand for? For example, if I type -10%, would it be 10% of 1 inch? And if I'm working in millimeters, would it be 0.1 millimeter?
Good question.
Yeah, that's. We probably need to change that option a little bit so that it's something other than percentage, and that will be coming in a future release. But it actually stands for 10% of the average edge size. So we take the average sort of edge size of the model and do 10% of it, and that, you know, it gives us a relative value instead of just picking a number as the default. So, you know, it's something that we've had requests to give a precise number for, and we are in the process of doing that. So you for example, will be able to type in inches and so on.
Very good question, though. I see Vadim, you asked that. Okay, are there other questions?
Let's see. Let's see. Whom should I contact about the educational licensing? I think Steve's very interested. I guess you can contact us, but then it might be good to ask you guys too as well, right, David?
Sure, you can contact us or you can contact Novedge, either one.
Okay, Andrew has this one. This one just came in. What are some general thoughts, strategies about how to begin from sketches, primitives, what shape primitives for what final shapes, etc.?
Well, it's one of those things that you probably have to play around with it to get a good idea. For example, if you have, you can actually create almost anything starting with a box. Sometimes it's more convenient to create other shapes just to get you closer to where you want to get without as much effort.
The one I find most useful is the torus, as far as that goes.
Yeah, torus is good for making rings and things like that. It's kind of hard to create a torus shape just kind of from a box and get everything nice and uniform. So
there was another question on the question list about importing scan meshes, so I'd like to handle that if you don't mind.
Absolutely, go for it.
We plan on adding the ability. Right now we can import subD models from any system. Scan meshes, we are in the process of adding through an extension product through Power Surfacing, which will be available pretty soon in a beta release. So look for that. It's pretty good.
Yeah, it will allow you to read in a scanned mesh and create a subD right on top of it, and it will snap down to it. And we'll have a different subdivision called interpolative subdivision, where it will interpolate the points that it goes through instead of kind of shrinking inside it.
It's going to be pretty nice. So whoever's asking for that, just if you're interested in participating in the beta test for that, just send an email to dgill@npowersoftware.com. That's on our webpage, that email address. Or you can send it to support or sales@npowersoftware.com.
Cool. Let's see. We have one from Doug. How do I manage parting lines for a molded part?
Oh, very good question.
Okay. You can actually, there is a thing on our website that goes through different scenarios of starting with a surface. And so let's say you have a single curve that goes around as your parting line. You can create a couple of surfaces off those and use those as starting points in the create from surface. And it uses the NURBS subdivision, so you'll have an exact, you actually will have an exact interpolation of that point, of that curve.
So that can be your parting line.
Yeah. And so there's a, if you bring up the.
I was just going to make a quick cylinder.
Okay.
Yeah.
That's
fine.
Right?
Yeah.
To pick up. So I'll go ahead. I'm just going to make a simple cylinder here. And we'll go ahead and extrude it. And one of the things I didn't show yet was that we can select any surface.
Any SolidWorks surface.
SolidWorks surface, yeah, excuse me on that.
And you could create a surface just by extruding the parting line.
And under our create options, we can do a create from surface. And remember, right now we're looking at the control mesh. If I switch it over to subD, you can see that it is the size of the surface there.
It's an exact replica of the surface.
Yeah. And as long as you stay far enough away from the edges, the boundaries, you could go ahead and do more modeling on this if you needed to.
Cool. All right. I think we have time for one more question. I'll let you guys pick. Go ahead, Gary. Whichever is most relevant.
Can you scroll the question so
to the very bottom? They're just coming in here. I love it. It's amazing. I wish we had
I like
a lot
the
of
one
time.
that it's better than T-splines. Can we answer that question?
We like that. Okay.
That's more of a comment anyway. But
No radial symmetry yet, but that's on our list.
yeah, very good question. These are great questions, by the way. So.
Cool. Which unfortunately means that we don't have a lot of time. But Michael, Vadim, Steve, Lenny, I do want to remind you guys that in the follow-up email, I have a link to the blog, and we'll format and forward all these questions to the Integrity-Aware team, and we'll make sure that they answer it. I think they would want to answer this as well. You know, it's going to be really cool. And then once it's ready, we'll have a link in our video page too. So one more question. What about that, guys? I feel bad for leaving them hanging, so take your pick.
That's a good question at the end, the 3D printing one. They're asking what software is required for 3D printing. And actually, we can use, with our software, we can generate STL output, which is watertight and ready for 3D printing. So you can use pretty much any software. You can import your OBJ files in here, and we can you can play around with them and adjust them or whatever. And then you can export to STL through our interface and generate the 3D print models.
Yeah, but you can use the SolidWorks printing stuff as well.
As well, yeah. And they have pretty good support, actually. A lot of the 3D printing companies interface directly to SolidWorks format.
Yeah, we in a couple of models we printed, we just sent up the SolidWorks file.
Yeah.
Okay, there's one that might be worth taking there.
Yes. You can take, that's what you were trying to show with the cylinder. You can take
in a limited extent.
Yeah.
Like, you know, single surfaces here and there. You can't just take the whole model in at the current time.
Yeah.
Cool.
We'll answer all these questions here. So we'll put them on the blog and we'll answer them all.
Absolutely. Okay. All right. In that case, I will take over the controls. I feel bad for doing this, but you know what? We're going to answer them. We're going to answer them. I'll make sure that they do. Okay.
So you know, we'll answer them all.
Cool. But yes, yeah. Thank you guys for joining us today. Let me get my thank you slide here. Thank you for attending, everybody. Yeah. So I'm going to get all these questions. I'm going to forward them to David, to Gary, to Sue, and then just make sure that they answer them, and then we'll share it on our blog post with the video as well, with links to the video as well. But I do want to say that if you guys are interested in picking up the latest version of Power Surfacing for SolidWorks, you guys can head on over to our product page. We are a reseller, and it is available from Novedge worldwide as digital delivery with 0 sales tax. So if you guys want more information, contact our specialist Bob there. You can get him. You can get at him with his email address, bob@novedge.com. And if you guys have any questions too after the webinar, forward them to us, and then we'll make the connection with the team at Integrity-Aware as well. Yeah, and if you guys have any other questions, like if you guys want support information, if you guys want to learn more about the product, we're not the only place that you can get information to as well. Head on over to nPower's website. They have tons of products as well, so do check it out as well there. And yes, we do have a blog. If you're looking for information for updates on upcoming promos and specials, links to the webinar, head on over to blog.novedge.com. And if you want the latest updates, facebook.com/Novedge will be the place to check out. So we do like likes. Yes, in our next upcoming webinar, this is coming up next week, we have Greg Hilmer, who's the author of Lightplot Deconstructed. He'll be taking excerpts from his book, and we'll be demonstrating features and capabilities of Vectorworks Spotlight 2014, which just came out this month too. So yeah, if you guys want more, head on over to novedge.com/webinar/89 to sign up for this free webinar. And the webinar is being recorded. It will be converted today, and I will upload it at vimeo.com/Novedge and youtube.com/Novedge. So please subscribe there. All right, on behalf of the Novedge team, I want to thank everybody for joining us today. David, Gary, Sue, do you guys have any last words before we sign off on this?
Well, I think everyone's headed off for lunch now, so I'm the only one left, but enjoyed having you guys as an audience.
Awesome, cool. All right, in that case, yeah, stay tuned. Have fun. Ciao.